So you're sitting there doing your nice little question, and there is your vector, something launched up this way, 10 meters per second at angle alpha. And rather than be nice and give you a nice number of degrees, like 32 or something, they instead say that tan of alpha is 40/9. How do you deal with this bundle of joy? Okay, sometimes your first instinct will be to figure out that alpha equals the tan inverse of 40/9, and you get a big messy number in degrees. This is not the way to go. All right, you got to remember, what are you really looking for? Well, often in a question like this, you're going to have to break this down into two different components of it. And this will be 10 cos alpha, the I direction, and 10 sine alpha in the j direction. So you don't really want alpha. What you really want instead is sine alpha and cos alpha. This is what we're actually looking for. So now, with that in mind, let's stand back for a second. Remember, the tan of an angle is the opposite over the adjacent. This is just a relationship between the three different sides of a triangle. So, again, with many things in applied maths, if in doubt, draw a diagram. So there's a triangle and there's alpha. So that means in this particular triangle, the opposite here is 40, and this one is 9. My triangle isn't even remotely to scale, but that doesn't really matter for the moment. All right. Oh, now what's this one here? Well, that's just a bit of Pythagoras to find our missing hypotenuse. We know that our hypotenuse, let's call it x for the moment, x squared is 40 squared plus 9 squared. All right. You bang that in your calculator, you're going to get that to be 1681. Doesn't that look fabulous? But actually it's not too bad, because x is the square root of 1681, and in this case that's just 41. So we know that our triangle is now 940 and hypotenuse of 41. Okay, sometimes that'll be a square root of something. If it is, leave it as a square root. So how do we use this? Coming back to our sine and cos. Well, the sine is the opposite over the hypotenuse. There we go, hypotenuse. And in that case, that's 40/41. That's very nice to work with if we're going to put it into our equation here. Similarly, the cos of the angle is the adjacent over the hypotenuse. And you do need to know these relationships, these three ones here. And that's going to be 9/41. So again, we can see it's just 10 by 9/41. So now, this is what we've been able to figure out. This is what we really need to know, the sine and the cos in our problem as we go forwards.